It's 2:47 a.m. Your payment system is down. Customer complaints are flooding in. Revenue is bleeding $50,000 per minute. Today we're taking you inside the chaos of a real production incident, where AI tools promised to help but sometimes made everything worse.
Sam, I've been through hundreds of incidents, but this one was different. We had ChatGPT suggesting solutions, Copilot generating monitoring queries, and AI-powered alerting systems firing constantly. The noise was deafening.
The irony was brutal. We built this AI-enhanced observability stack to prevent exactly this kind of outage. Instead, when we needed clarity most, the AI was giving us contradictory suggestions every 30 seconds.
Let me paint the picture. 2:30 a.m. our primary payment database starts timing out, connection pool exhausted, AI monitoring immediately suggests scale horizontally and increase connection limits simultaneously. Both can't be right.
Meanwhile, our AI-powered network analyzer is screaming about anomalous traffic patterns and recommending we implement rate limiting. But we can't tell if it's legitimate traffic or a symptom of the database issues.
At 2:35 a.m., I made the call to ignore all AI suggestions and go back to fundamentals. We had junior engineers asking ChatGPT for PostgreSQL tuning advice while the database was literally melting down.
I was that junior engineer. Maya's right, I was frantically copying PostgreSQL queries from ChatGPT into our production console. In hindsight, that was terrifying. I could have made everything worse.
Alex, we've all been there, but this incident exposed a fundamental problem. When systems are failing, AI amplifies chaos instead of reducing it. Every tool was suggesting different root causes.
Walk us through the timeline. How did this cascade failure actually unfold, and where did the AI tools help versus hurt?
2:30 a.m. database connection timeouts start. Our AI alerting system immediately fires 47 different alerts. Slack channels exploding with automated messages. Signal lost in the noise.
2:32 a.m. network monitoring AI detects unusual patterns and auto-enables DDoS protection. This actually throttles legitimate payment traffic, making the problem worse. Classic AI false positive.
2:33 a.m., I'm trying to understand the scope while ChatGPT is suggesting we restart the database cluster. That's a 10-minute operation during peak revenue hours. Absolutely not happening.
2:34 a.m., I asked GitHub Copilot to generate a query to find slow transactions. It gives me a query that would lock the entire database for analysis. Maya caught me before I ran it.
Meanwhile, our Kubernetes AI autoscaler is spinning up 200% more pods because it thinks we're under load. But the issue is database connections, not compute. We're burning money on useless containers.
2:35 a.m., I manually check PG stat activity and see something the AI missed. 847 idle connections from a single microservice. Someone deployed code with a connection leak. No AI tool caught this.
There's the root cause, but now we have 3 different AI systems suggesting 3 different fixes. Kill all connections, restart the service, or scale the database. Decision paralysis at 2:37 a.m.
The network AI is still convinced it's a DDoS attack because traffic patterns look abnormal. It's trying to black hole IP ranges that include our own load balancers. I had to manually override it.
2:39 a.m. I identify the leaky microservice. User profile API deployed 6 hours ago. But our AI deployment analyzer marked it as low risk because the code changes looked minimal.
I wrote that deployment. One-line change, switching from connection pooling to direct connections for better performance. ChatGPT suggested it. I didn't understand the implications.
Alex, that's exactly the problem. AI gives you code that works in isolation but doesn't understand production constraints. Connection pooling exists for a reason at scale.
2:41 a.m. decision time. Do we roll back the deployment, restart the service, or kill connections manually? The AI tools are giving conflicting recommendations with confidence scores above 90%.
I vote rollback, but our AI-powered deployment system says the previous version had security vulnerabilities and blocks the rollback. We're trapped by our own automation.
The network monitoring AI just escalated to our CTO because it detected critical infrastructure compromise. Now we have executives asking questions while we're trying to debug.
2:43 a.m., I manually kill the idle connections from user profile API. Database performance immediately improves. Sometimes you need human judgment to cut through the AI noise.
But we still have the leaky service running. Every new request creates another connection that never gets closed. We're buying time, not solving the problem.
2:45 a.m., I make the executive decision. We're manually overriding the AI deployment blocker and rolling back user profile API. Revenue loss trumps theoretical security concerns.
The rollback triggers 15 more AI alerts about unsafe deployment practices and security policy violations. The noise is incredible. We can barely think.
2:47 a.m. rollback complete. Traffic normalizes. Database connections drop to healthy levels. The AI network analyzer finally realizes it wasn't a DDoS and stops its protection measures.
Total downtime, 17 minutes. Revenue impact, $850,000. Half the downtime was caused by AI tools giving conflicting advice and blocking our remediation efforts.
So the AI tools that were supposed to prevent and resolve incidents actually prolonged this one. What lessons did you learn about AI in production environments?
First lesson, AI suggestions without context are dangerous. Every tool gave confident recommendations without understanding our specific constraints, business impact, or risk tolerance.
Second lesson, AI amplifies noise during high-stress situations. When you're debugging at 3 a.m., the last thing you need is 50 different automated suggestions contradicting each other.
Third lesson, junior engineers and AI are a dangerous combination. I trusted ChatGPT's connection pooling advice without understanding the production implications. Almost made it worse.
Fourth lesson, AI sees patterns but misses context. No AI tool identified the connection leak because it looked like normal database activity in isolation.
Fifth lesson, AI automation can trap you. Our deployment system blocked the rollback because AI flagged security issues. Sometimes you need manual overrides.
But here's the thing, AI wasn't entirely useless. Our AI log analysis did help us correlate the timing between the deployment and the connection spike. That was valuable.
And GitHub Copilot actually generated some useful monitoring queries once Alex learned to ask better questions. The tool isn't bad, but the user needs experience.
The AI alerting system did notify us within 2 minutes of the problem starting. The issue was the signal-to-noise ratio, 47 alerts, when we needed maybe 3 focused ones.
It sounds like the problem isn't AI itself, but how it's integrated into high-pressure production environments. How do you fix that?
We implemented AI circuit breakers. During active incidents, we automatically suppress non-critical AI suggestions and only show high-confidence, actionable recommendations.
We also added context to AI alerts. Instead of just saying, anomalous traffic detected, it now explains what's anomalous and suggests specific investigation steps.
I learned to use AI as a research assistant, not an authority. Now I ask it to explain concepts and generate options, then validate everything with senior engineers before implementing.
We created AI confidence thresholds. Deployment blocks only trigger for high-severity issues with 95% plus confidence. Medium confidence issues become warnings with manual override options.
Most importantly, we established AI-free escalation paths. If an incident hits critical severity, we have procedures that bypass all AI automation and rely on human judgment.
Let's dig deeper into specific moments where AI helped versus hurt. Can you give us more concrete examples?
AI helped. Log analysis found the correlation between deployment timestamp and connection spike within seconds. Would have taken us 10 minutes manually searching logs.
AI hurt. Kubernetes autoscaler kept spinning up pods based on CPU pressure that was actually caused by connection waiting, not processing load. Wasted $3,000 in cloud costs.
AI helped. ChatGPT explained why connection pooling matters in production environments. I finally understood the concept. AI hurt. It suggested code changes without explaining the trade-offs.
AI helped. Automated query analysis identified which tables were experiencing lock contention. AI hurt. Suggested aggressive indexing strategies that would have made writes slower.
AI helped. Traffic pattern analysis showed the exact microservice generating anomalous connection patterns. AI hurt. DDoS protection false positive blocked legitimate traffic for 8 minutes.
The pattern is clear. AI excels at data analysis and pattern recognition. AI struggles with context-dependent decisions and understanding business trade-offs.
But here's what scared me most. Alex almost ran that table locking query because ChatGPT presented it confidently. Junior engineers trust AI suggestions without understanding the implications.
That's fair criticism. I was treating ChatGPT like a senior engineer mentor, but it doesn't have judgment about production safety. It just generates syntactically correct code.
Which brings up a critical point. We need AI literacy training for engineers, understanding what AI can and can't do safely in production environments.
Let's talk about the business impact. $850,000 in lost revenue. How much of that was avoidable if you'd handled the AI tools differently?
Honestly, if we'd ignored the AI suggestions and gone straight to manual debugging, we could have resolved this in 8 to 10 minutes instead of 17. That's about $400,000 in avoidable losses.
The DDoS protection false positive alone cost us 8 minutes of additional downtime. That's because the AI was too eager to help without understanding the context.
The deployment system blocking our rollback added another 3 minutes. We had to escalate to override the AI security policy. That delay was pure AI obstinacy.
But let's be honest, the root cause was my deployment with ChatGPT suggested code. Without that, there wouldn't have been an incident at all. AI created the problem.
That's the deeper issue. AI tools make it easy for inexperienced engineers to deploy dangerous code with confidence. The code looks correct, compiles fine, but breaks under load.
We calculated that AI-related delays and decisions cost us about 60% of the total downtime. That's a $500,000 lesson in AI integration done wrong.
Let's get specific about the moment-by-moment decision-making. Maya, when did you realize the AI tools were making things worse?
2:37 a.m. exactly. I had 3 different AI systems giving me contradictory advice with identical confidence scores. ChatGPT said restart the database. The monitoring AI said scale horizontally. Copilot suggested connection tuning.
I remember that moment. Maya just said everybody stop asking the robots and start looking at the actual data. It was like a switch flipped in the room.
That's when I went back to basics, manually checking PG stat activity instead of relying on AI analysis. Found the connection leak in 30 seconds of manual inspection.
I was still frantically asking ChatGPT for PostgreSQL debugging commands. Maya had to physically walk over and close my laptop. Said, "Alex, the AI doesn't know our system. You need to think."
Meanwhile, I'm fighting with the network AI that's convinced we're under attack. It kept auto-enabling protection measures that blocked legitimate traffic. Had to disable it completely.
The turning point was when we stopped treating AI as an oracle and started treating it as noisy background information. Once we did that, we could actually debug effectively.
But here's the irony. After we solved the incident manually, the AI log analysis confirmed our root cause and showed us the exact timeline. It was helpful in retrospect, useless during the crisis.
That's fascinating. AI as a post-mortem tool versus a real-time debugging tool. What does that tell us about where AI actually belongs in incident response?
AI is excellent for preparation and analysis, terrible for real-time decision-making under pressure. It can help you understand what happened, but not what to do while it's happening.
Think of AI like a very knowledgeable intern who panics under pressure. Great at research, analysis, and generating options. But you wouldn't let an intern make critical decisions during a production incident.
That's a perfect analogy. I was treating ChatGPT like a senior engineer, but it's more like a really smart junior who's never seen production failures before.
We've restructured our incident response. AI tools for data gathering and option generation, humans for decision-making and execution. Clear separation of responsibilities.
And we added AI skepticism to our runbooks. If multiple AI systems disagree, ignore them and rely on human analysis. Contradictory AI advice is worse than no advice.
Let's talk about the aftermath. How did your organization change its approach to AI in production systems after this incident?
We implemented incident mode for all AI systems. During active incidents, AI suggestions are logged but not displayed to reduce cognitive load. Teams can review them post-incident.
We created mandatory AI safety training. Junior engineers now need senior approval before implementing any AI-generated code suggestions in production systems.
All AI-powered automation now has manual override capabilities with no approval required during P0, P1 incidents. No more being trapped by our own helpful systems.
We established AI-free debugging protocols. When incidents hit critical severity, we have procedures that rely entirely on human expertise and manual investigation.
Network monitoring AI now has context awareness. It considers recent deployments, known maintenance windows, and business events before triggering automated responses.
Most importantly, we changed our culture. AI suggestions are treated as starting points for investigation, not final answers. Humans always make the final decisions.
Alex, you mentioned your role in creating the original problem. How has your relationship with AI coding assistants changed?
I was naive. I thought ChatGPT understood production constraints because it gave me syntactically correct code. I didn't realize it was optimizing for code simplicity, not production safety.
The connection pooling example is perfect. ChatGPT suggested direct connections because they're simpler and more performant. Technically true, but ignores resource management at scale.
Now I use AI differently. I ask it to explain concepts, generate multiple implementation options, and highlight trade-offs. Then I discuss everything with senior engineers before implementing.
That's the right approach. AI as a research assistant, not a decision maker. It can help you understand options, but you need human judgment to choose the right one for your specific context.
We've seen this pattern across the industry. Junior engineers using AI coding assistants create more subtle, hard-to-debug production issues than before. The code works until it doesn't.
That's a concerning trend. Are we creating a generation of engineers who can write code but don't understand production implications?
That's exactly the risk. AI makes it easy to write code that looks professional but lacks production resilience. It's like giving someone a Formula One car without teaching them about road safety.
I felt like I was learning faster with AI help, but I was actually skipping fundamental concepts. I could implement features without understanding the underlying systems.
We need to teach engineers to interrogate AI suggestions. Ask what could go wrong, what are the resource implications, how does this behave under load? AI doesn't volunteer that information.
The solution isn't to ban AI tools, but to teach engineers when and how to use them safely. Like teaching someone to drive, the car is powerful, but you need rules and judgment.
We implemented AI code review processes. Any AI-generated code gets extra scrutiny for production implications, resource usage, and failure modes.
Let's talk about the specific technical lessons. Sarah, from a database perspective, what did this incident teach you about AI monitoring tools?
AI monitoring tools excel at detecting patterns but struggle with context. They saw 847 connections and flagged it as high usage instead of recognizing it as a leak from a single service.
Same with network monitoring. The AI saw unusual traffic patterns, but couldn't distinguish between legitimate load and problematic behavior. Context is everything.
The autoscaler actually made things worse by creating more services that would eventually leak more connections. It was amplifying the problem while thinking it was solving it.
This is why we now have AI correlation analysis. Before any automated action, the system checks if multiple metrics point to the same root cause. No more isolated decisions.
I learned that AI suggestions need human validation at every step. Just because ChatGPT gives you PostgreSQL commands doesn't mean you should run them on a production database.
Marcus, the DDoS protection false positive seems particularly dangerous. How do you prevent AI security tools from becoming the attack vector?
That's the nightmare scenario. Your security AI becomes the threat. It blocked legitimate payment traffic for 8 minutes because the patterns looked suspicious. No human would have made that mistake.
AI security tools are trained on attack patterns, but production incidents can mimic attacks. Database overload creates traffic spikes that look like DDoS to pattern-matching algorithms.
We implemented gentle degradation policies. AI security tools now throttle gradually and alert humans instead of immediately blocking traffic. Humans make the final blocking decisions.
The key insight is that AI sees patterns, not causation. It detected anomalous traffic, but couldn't understand that the traffic was legitimate users being impacted by our database issues.
We also added incident awareness to all automated systems. During active incidents, AI tools operate in advisory mode only. No automated actions that could compound the problem.
Let's dive into the deployment system blocking your rollback. David, how did AI deployment security become an obstacle to incident resolution?
Our AI security scanner flagged the previous version as having potential SQL injection vulnerabilities because it used dynamic queries, but those were actually safe parameterized queries.
The irony is that my secure, new version with ChatGPT's connection handling was causing the actual production damage. The AI prioritized theoretical security over operational reality.
This is a perfect example of AI not understanding risk context. A theoretical SQL injection risk is less important than active revenue loss from database failures.
We had to escalate to our security team lead to override the AI blocker. That added 3 minutes to our incident response time while losing $50,000 per minute.
Now we have incident overrides for all AI policies. During P0, P1 incidents, human operators can bypass any AI blocker with incident ticket justification.
The lesson is that AI operates in perfect world scenarios. It doesn't understand that sometimes you need to choose between bad and worse options during a crisis.
This brings up a fascinating point about AI and risk assessment. How do you teach AI systems to understand business context and acceptable risk levels?
That's the million-dollar question. AI systems need to understand that $850,000 in lost revenue outweighs theoretical security risks. But how do you encode business judgment into algorithms?
We're experimenting with business impact scoring for AI decisions. High revenue impact incidents automatically lower AI security thresholds and enable emergency overrides.
But even that's dangerous. What if an attacker triggers a fake incident to lower security thresholds? AI can't distinguish between legitimate emergencies and social engineering.
Maybe that's the point. Some decisions are too complex for AI because they require understanding human motivations, business strategy, and acceptable risk trade-offs.
I think we need to accept that AI is a tool, not a replacement for human judgment. It can inform decisions but shouldn't make final calls during complex situations.
Let's talk about the human psychology aspect. How did the stress of the incident affect how your team interacted with AI tools?
Under pressure, I was desperately asking ChatGPT for quick fixes. The stress made me more likely to trust AI suggestions without thinking them through. Panic mode, AI equals dangerous combination.
I noticed the team splitting into two camps, those frantically consulting AI tools and those who immediately went back to manual debugging. Experience levels seemed to predict the response.
The junior engineers were treating AI like a magic solution. ChatGPT will know what to do. But senior engineers were more skeptical because we've seen too many AI false positives before.
Stress also made us more susceptible to confirmation bias. When AI suggested something we wanted to hear, like just restart the service, we were tempted to accept it without analysis.
The constant AI alerts and suggestions created decision paralysis. Too many options, all presented with false confidence. Sometimes less information is better during a crisis.
That's why we implemented cognitive load management. During incidents, AI suggestions are filtered to show only the top 3 most relevant recommendations, not 47 alerts.
As we wrap up, what would you tell other engineering teams about integrating AI into their production operations?
AI is a powerful assistant but a terrible manager. Use it for data analysis, pattern detection, and option generation. Never let it make critical decisions without human oversight.
If you're a junior engineer, treat AI like a very smart intern who's never worked in production. Get multiple opinions, validate everything, and always involve senior engineers in final decisions.
Build AI circuit breakers into all automated systems. When things go wrong, you need the ability to quickly revert to manual operations without fighting your own automation.
Understand AI limitations in your specific domain. Database AI tools understand queries but not production constraints. Network AI sees patterns but not business context.
Test your AI systems under pressure before you need them. How do they behave during incidents? Do they amplify chaos or reduce it? Fix the problems before they matter.
Most importantly, maintain human expertise. AI can augment human skills but can't replace domain knowledge and production experience. Keep investing in your people.
Any final thoughts on the future of AI in production environments?
I think we'll find the right balance eventually. AI for research and analysis, humans for judgment and decisions. But we need better education about AI limitations.
The technology will improve, but the fundamental challenge remains: AI lacks context about business priorities, risk tolerance, and acceptable trade-offs. That requires human judgment.
We need AI tools designed specifically for production environments, not general-purpose tools adapted for production. Different requirements, different safety considerations.
And we need industry standards for AI safety in production systems. Clear guidelines about when AI should and shouldn't make automated decisions.
The goal isn't to eliminate AI from production, it's too valuable for that. The goal is to use it thoughtfully, with appropriate guardrails and human oversight.
This has been an incredibly revealing look at AI in production environments. Maya, Alex, David, Sarah, Marcus, thank you for sharing this honest analysis of what went wrong and how you fixed it.
Thanks for giving us a platform to share these lessons. If our $850,000 mistake helps other teams avoid similar problems, then something good came out of it.
I hope junior engineers listening to this understand that AI is a tool to enhance your learning, not replace your thinking. Ask questions, validate everything, and learn from experienced engineers.
The future of engineering is humans and AI working together effectively. But that requires understanding what each brings to the table and respecting the limitations.
Remember, production systems are about reliability, not just functionality. AI suggestions that work in development can fail catastrophically under production load.
Stay curious, stay skeptical, and always have a manual fallback plan. AI will get better, but human judgment will always be essential for complex systems.
This episode was brought to you by Unstruct AI, creating the most trusted AI news analysis platform, with a focus on the human cost. After all, progress without humanity isn't progress at all. Next week, we'll explore how AI coding assistants are changing software development practices and whether we're creating more reliable or more fragile systems. Until then, question the algorithms, trust human expertise, and remember, when your production system is on fire, sometimes the best AI strategy is to turn off the AI. This has been Unstruct AI, where we examine technology's human impact. Thanks for listening.